Hello, welcome to the Self-Learning Podcast by Dr. Sushma Singh. Let us start discussion on Unit 15, Sampling Methods and Estimation of Sample Size. And we are discussing non-probability sampling. The first one is convenience sampling. Convenience sampling is used in exploratory research where the investigator is interested in getting an inexpensive approximation of the fact. As the name implies, the sample is selected because it is convenient, also called haphazard or accidental. This method is based on using people who are a captive audience, just happen to be walking by, or show a special interest in research. The use of volunteers is an example of the convenience sampling. This method is often used during preliminary research efforts to get a gross estimate of the results without incurring the cost or time required to select a random sample. The next one is judgment sampling. Judgment sampling is common non-probability method. The researcher selects the sample based on judgment. This is usually an extension of convenience sampling. For example, a researcher may decide to draw the entire sample from one representative village, even though the population may be distributed over a number of villages. When using this method, the researcher feels that the chosen sample is representative of the entire population. The next method is purposive sampling. Much similar to judgment sampling is when the researcher targets a group of people believed to be typical or average, or a group specially picked up for some unique purpose. The research never knows if the sample is representative of the population, and this method is largely limited to the exploratory research. The next one is quota sampling. Quota sampling is the non-probability equivalent of stratified sampling. Like stratified sampling, the researcher first identifies the strata and then proportions of the population. Then convenience or judgment sampling is used to select the required number of subjects from each stratum. The researcher resorts to haphazard or accidental sampling and makes no effort to contact people who are difficult to reach. This differs from stratified sampling, where the strata are filled by random sampling. Now the next is snowball sampling. Snowball sampling is a special non-probability method used when the desired sample characteristics is rare. It may be extremely difficult for cost prohibitive to locate respondents in these situations. Snowball sampling relies on referrals from initial subjects to generate additional subjects. In other words, snowball sampling comprises identification of respondents who in turn refer researches to other respondents. This technique provides a means to access relatively visible and vulnerable social groups. While this technique can dramatically lower the search costs, it comes at the expense of introducing bias, because the technique itself reduces the likelihood that the sample will represent a good cross-section of the population. For example, an investigator finds a rare genetic trait in a person and starts tracing his pedigree to understand the origin, inheritance, and etiology of the disease. You may have heard that only quantitative researches require sampling. The fact is that qualitative researches use sampling procedures. Now let us move to the next point, sample size. A prudent choice of the sample size for a particular survey involves many considerations, among which are the resources in manpower, cost per sample units, and funds available. The number and type of parameters to be estimated. Obviously, these specifics will vary from one survey to another. All the same, a framework can be constructed within which general and viable decisions with respect to sample size can be taken. Sampling theory aids in arriving at good estimates of the sample size. The standard error here too provides the key. Apart from the size of the universe, the sample size may depend on the following conditions: the confidence limit set up for estimation, the heterogeneity of the population, and frequency or proportion of the trait or attribute to be examined. The estimation of sample size also differs according to the purpose or the parameter under investigation. For example, whether sample size is being estimated for calculating mean or proportion or for comparing means. Two cases, namely the estimation of the mean of a normally distributed variable and the estimation of a proportion. In these cases, there are two assumptions. First, that the sampling is simple, random, and without replacement. And second, the population sampled is infinitely large. Now let us conclude the unit. In this unit, we discussed the important subject of sampling and provided you with relevant information on different methods of sampling. Further, it brought to you the skills of calculating the sample size. You may like to keep in mind what Mitchell said about sampling theory in statistics, that it devotes itself to providing numerical estimates of the likelihood that the population values be within some defined range of that established from the sample, provided that the sample has been chosen in such a way as to meet the mathematical conditions to justify the computation of the probabilities concerned. Further, he clarified about another type of inference that is derived while using quantitative data to support theoretical interpretation, and said the sophistication and elaboration for choosing a representative sample in this restricted sense has overshadowed the other kinds of inference involved when analytical statements are made from associations uncovered in a statistical sample. This is the inference that the theoretical relationship among conceptually defined elements in the sample will also apply in the parent population. The basis of an inference of this sort is the cogency of the theoretical argument linking the elements in an intangible way rather than statistical representativeness of the sample. Now let us wind up the session, and we have come to the end of the unit. Thank you very much for engaging yourself with a self-learning podcast.